Imagine that you're driving down the highway when suddenly your car starts to shake violently. Alarms blare and lights flash as you realize you're in the middle of an earthquake. In that terrifying moment, you desperately want to know, how strong is this earthquake? How long will it last? Is it over? You need answers fast. But even if you had a phone with internet access, what would you search for? A website that tells you the strength of earthquakes. Good luck finding one, because they don't exist. In fact, there isn't a single global authority that tracks earthquakes in real time and posts the results online. Instead, different agencies around the world maintain their own databases. And even worse, they might use completely different scales to describe the same event. It's enough to make your head spin. So let us look at how scientists measure the size of an earthquake and why they use so many different numbers to describe it. There are two main ways of measuring earthquakes. The first is based on the size of the earthquake, or its magnitude, while the second measures the strength of the shaking at a particular location, or its intensity. Let's start with the big one. To measure the size of an earthquake, we need to determine the amount of energy released by the earthquake source, also called the seismic moment. That sounds easy enough, but it turns out it's not all that simple. One reason is that earthquakes can be very different from each other, which makes comparing them difficult. For example, in a shallow crustal earthquake, the waves radiate out in all directions from the source, while in a deep intraslab earthquake, the waves come from a much more confined angle. Also, surface waves that travel along Earth's surface tend to be more destructive than body waves that travel through the ground. Because of these differences, there are several different ways of measuring the size of an earthquake, depending on the kind of earthquake and the purpose of the study. One of the most widely used scales to measure the magnitude of smaller earthquakes is the Richter scale. It was invented in the 1930s by Charles F. Richter, a seismologist at the California Institute of Technology, who wanted an easy way to quickly estimate the strength of earthquakes recorded by local seismographs. The original Richter scale is calculated from the maximum amplitude of the largest wave, called the S wave, recorded on a standard seismograph at a distance of about 100 kilometers from the earthquake's epicenter. Today, seismologists have improved Richter's method, but it still serves as the basis for the local magnitude scale, ML, which is appropriate for small earthquakes with depths less than 70 kilometers that occur within 200 kilometers of a seismograph. The Richter scale has some practical advantages. It uses a logarithmic scale, where each whole number increase represents a 10 times greater amplitude and about 31.6 times more energy released than the previous one. For example, a magnitude for earthquake is 4 times stronger than a magnitude 3 earthquake and releases about 30 times more energy. This means that a magnitude 7 earthquake releases roughly 30, or 27,000 times more energy than a magnitude for earthquake. Another advantage of the Richter scale is that it can be calculated quickly, because it only takes into account the largest wave recorded on a standard seismograph. This means that the Richter magnitude can be determined within minutes of an earthquake occurring, making it useful for emergency response purposes. But like most things in science, the Richter scale has some limitations. Because it was designed for small local earthquakes, it doesn't work well for larger earthquakes. In fact, the Richter scale can only accurately measure earthquakes up to a magnitude of about 6 or 6.5. For larger earthquakes, the formula doesn't take into account the contribution of the surface waves, which are often the most damaging. Moreover, the Richter scale assumes that the earthquake source is a simple point source that radiates waves uniformly in all directions. But in reality, the source of large earthquakes is more complex and may rupture along a fault line that is unstraight or that lies at an angle. The complexity of the source combined with the non-uniform release of energy makes it difficult to relate the largest wave amplitude to the total energy released. These issues motivated the development of alternative scales to measure the strength of bigger earthquakes. One such scale is the moment magnitude scale, which is now the most widely used scale for measuring the size of earthquakes regardless of their depth or location. The moment magnitude, M, takes into account all the contributions to the seismic wave energy, including the energy released by the initial rupture and the subsequent afterslip, because it uses the seismic moment, which takes into account the entire earthquake source. The moment magnitude scale provides a better estimate of the total energy released during an earthquake than the Richter scale. In addition, the moment magnitude scale is a more precise measure of the strength of an earthquake, because it uses data from multiple seismographs around the world. Like the Richter scale, the moment magnitude is also a logarithmic scale, meaning that each whole number increase indicates a 10 times greater amplitude and roughly 32 times more energy released. However, unlike the Richter scale, the moment magnitude does not stop increasing at about magnitude 6 or 6.5. In fact, the highest recorded earthquake ever had a moment magnitude of 9.5. Okay, so those are the scales for measuring the size of an earthquake. But what if you were standing in the middle of an earthquake and wanted to know how strong the shaking was? Were you restanding? That's where the intensity of an earthquake comes in. Unlike the magnitude, which is a measure of the size of an earthquake, the intensity measures the strength of the earthquake at a particular location. There are several different scales to measure the intensity of an earthquake. Perhaps the oldest and most familiar is the modified Mercalli intensity scale, also known as the scale. This scale, developed in the early 1900s by Italian seismologist Mario Mercalli, is based on the effects of earthquakes on structures and people and is therefore subjective and varies from location to location. For example, according to the scale, the intensity of an earthquake could be described as minor if you felt it, but it was unstrong enough to disturb objects that are unpermanently attached, or as violent. If houses are severely damaged and many people are injured or killed, because the Mercalli scale is based on observed effects, the intensity of an earthquake can be determined before all the scientific data is collected and analyzed. This can be particularly useful in areas that are not well instrumented with seismographs. However, a major drawback of the Mercalli scale is that it's not very precise and depends on the person doing the reporting. Nevertheless, it remains a valuable tool for assessing the impact of earthquakes on people and infrastructure. So the next time you find yourself in the middle of an earthquake, here's what you do. First, drop to your knees to reduce the impact on your spine. Then protect your head and take cover under a sturdy desk or table. If there isn't any furniture nearby, protect your head and keep your feet apart to lower your center of gravity and stay on your feet. Once the shaking stops, check yourself for injuries and help others who may be hurt. If you're outside during an earthquake, stay there until the shaking stops. If you're driving, pull over to the side of the road and set the parking brake. Do not get out of the car. After the earthquake has passed, check for damage to your vehicle and proceed cautiously. Remember, earthquakes only last for a few seconds, but their effects can be felt for years. By understanding the different ways that earthquakes are measured, you can better prepare for and respond to these powerful natural disasters. Stay safe out there, everyone. And thanks for watching this episode of Sea Show. To learn more about earthquakes, their causes and effects, and how to prepare for them, visit our educational website.